All right. Sorry. Let's see. Hopefully I'm live. I guess so. All right. Um, welcome back to the stream. Let me try to see if my stream is working properly. All right. Uh, so I'll just open this. Okay, it's working. It's working. Yeah. So yesterday I did a revision on um um there are some things I revised yesterday, which is on how to implement a linked list, how to print a linked list, and how to reverse a linked list, right? So that is what I did yesterday. Let me just quickly bring it back up. So here's our implementation. Oh, surprisingly, I didn't push this to GitHub. Wow. Well, it's in the linked list basics. So everything it was still on GitHub. I just repeated the steps yesterday. So I'm going to cover these questions that I have here, right? So I'll solve these questions here. And where is it? Let's move it to the side. So here's the question we have. Maximum twin of a linked list. Instead of solving this one, why don't we solve the easy one? Because it's two questions, right? There are two questions. So I started with this, right? Okay, so let's do this. Um, this is a palindromic question or a palindrome question. That is at the same time a linked list question. So the question says, given let me just close this. This is distracting me. Um, okay. So, given the head of a singly linked list, return true if it's a palindrome, and return false if it's not, otherwise, if it's something else. So, we know what a palindrome is. A palindrome is a sequence that reads the same forward and backwards. So, I've done, quite a number of palindrome questions here. I've solved some palindrome questions. In fact, I have them on GitHub, so you can have a look at that. I think most of the palindrome question I did was either two pointers or stack questions. So this matrix sliding window, two pointers. Yeah, you can see we have a palindrome question here, and we have another palindrome question here as well. These are very interesting questions. They are medium level questions as well. So you be sure to have a look at that and see how I solve these questions, and try to practice with those questions as well. The link is in the description if you need any of this. So let's go ahead with the next question. I mean, the question of the day, right? So we want to verify if this string is a palindrome, and we know a palindrome is a string that can be written the same the same way forward and backwards. Now, in terms of arrays, we would have known, okay, let me come here. So say we have a palindrome. Okay, this is everything I did yesterday. I don't think I'll need these, right? So I'll just erase this quickly. Come on, cancel, delete. Okay. So a palindrome is a string that reads the same way forward and backwards, right? So let's say, for instance, we have R A R, right? I've used this example so much that when I'm explaining palindromes, it just comes up first. So this string here is a palindrome. This here, right, is also a palindrome. When you reverse this string, when you reverse this string, right? Let's say this is 1, this is 2. Okay, let's start from the beginning. This is 1, this is 2, this is 3. If you change the position of each character, right, in the string, right, it will read the same. It will read the same. You can see this is RAR, this is also RAR, right? And the same goes for this one here, right? This is known. So when we start this 1 2 3 4, when we do this known, right, sorry, when we want to put the last one in front, so N4 0 3 0 2 N1, right, this still reads the same. We know that the reverse is also the same as the start, right? Now, another way to another way to look at palindromes um, is such that when we have two types of palindrome, or we have two strings that can possibly be a palindrome, right? We have a palindrome with a single middle, right? And we have a palindrome with a double middle, right? In either case, right, when we take the strings from the middle, right, we need to, when we have the string, let's say we have this RAR, right? When we have this, let's say we start from here all the way here, and we compare this half with the other half, right? Let me start this. I'll write the string back again. RAR. So we have R, A, and then R. Now, when we take half of this string, right, a palindrome with a single middle, right, when we take half of this string and reverse this half, right, we'll get RA, right? And then when we take half of the original string in the correct order, we'll also get RA, right? When we compare these two, we'll see R here, right, which is the same as this R in the reverse form, and A2 here, A is also here as well. So we know this string is a valid palindrome. That's one way to check it. Another way is to simply reverse both, right? You reverse RAR, right, to RAI again, right? And this, you just compare it straight away. Compare the original string with its reverse. But, reversing a string, reversing characters in a string is quite, time consuming. At least it's going to be a O of N operation in terms of linked lists, right? Because linked lists don't have indexes for us to even know where to start from, or to even get the middle in the first place. So since that's going to take time, right, we'll use half, right, reverse the half, and then compare the values at each position within the half and the original string, right? Now, that's one way to do it, and I think pretty okay. So I just explained two ways. The first way is to take the original string, divide it into two, reverse the second half, and compare it to the first half, right? Or you could just reverse the entire string, right? Have a copy of the string, reverse it, keep a reverse version of the string, and compare it to the original version. When you compare those two, and each character is the same, right? Or every character in a particular position is the same as the one in either string, right? So if this R is here, if this R is the first character in the original string, then R, which is also in front here, should also be the first character in the reverse form, right? So that's one way to do it, but reversing the entire string actually takes a lot of time to compute. Not a lot of time per se, but like, I don't want to exaggerate it, but it would be best to reverse half of the string instead of the entire string itself, right? Either way, the operation is still going to be O of n, but this time around, it will help us, limit how many reversal operation we want to operate, we want to effectuate, right? I mean, we want to, oh, God, we want to perform. Christ, I spoke some French there. Okay, so let's see what we can do now. So, oh, somebody said, hey, I wanted to know your name, your branch. Yes, let me know when you're done with the question, or if you have time to respond. Oh, um, thanks for asking. Hold on. Sorry, I usually have emergencies like this, so it will require me to take some time off and you know just attend to it quickly. So my name is Wilfred. My name is Wilfred. So Wilfred is my name. Let me type it here like this. Wilfred. Oh, hold on. Something just happened. Hope I didn't end my stream. Ha. Wait. Oh my god. Please don't tell me I ended the stream. Okay, I'm still live. Let's just see. Hello? Yes? I promise that's like one out of two more calls that will be coming in before I switch off my phone. So let me quickly respond. So my name is Wilfred. I'll type my name here. Wilfred. Wilfred is my name. And yeah, that's my name. So second question is your experience in CS and let me know when oh, okay. So my experience in CS. Well, I didn't study computer science. Actually, I didn't study computer science. In fact, I didn't go to university. I didn't complete university. Let me just put it that way. I haven't completed university. So yeah, I'm I just started, you know, uh coding out of interest back in 2020 2021. Yeah. So I mean, there have been pauses in between, so I wasn't doing it full time until last year. Yeah, 2022. So last year, last 2 years. Yeah, but I've been working solo, right? But the point is to advance one's career and get more stuff done. So which is why I'm here. Okay. Instead of me okay, so that's about me. Um, I will put that in the description, but yeah, let me complete this course for today and continue um answering more questions. But before then, 1 minute to respond to something quickly. All right. So I don't know. These people wait until I start my stream before they start calling me. Okay. So where was I? Where was I? Let me go back to my original screen. Okay. So we have this palindrome, right? That's how we're going to check a palindrome. We're either going to use half of it, right? We take the original input, divide it into half, reverse it, and compare the values. But this time around, we are not going to use strings, right? We're not going to use strings. Instead, we'll be giving integers to check as palindromes, right? To check if they are valid palindromes or not, or if they are palindromes or not. Sorry. So let me put this here. I would say this will be one, right? Let me use a white color. This will help me. So this is 1 2 2 1, right? 1 2 2 1, right? It's a valid palindrome. Why is this a valid palindrome? If we take this half of this string, right? If we take half of this string, we'll have let me just use this. We'll have one, we'll have 2 1, right? Now when we reverse this string, right, we'll get 2 1 and 2, right? And if we begin to compare it to half of the original string, right, this is 1 and 2 as well as this one. So this string is a valid palindrome. Now let me go over that again. Say we want to validate this, we want to check if this string is a valid palindrome. First of all, here's a method to do it. We take half of this string, right? The half of this string is from 2 all the way to 1. Now, or let's say this integer, I mean, this an input. We can call it a string, we can call it whatever, but I'm just saying this input, right? This integer 1 2 2 1, right? We want to check if this is a valid palindrome. So we take half of it, right? Half of this is this part here. And when we reverse this half, right? When we reverse this half, we'll get 1 and 2. Now we'll compare this reversed version to the original half, right? We'll take half again, half, but from the beginning this time around, right? We'll compare it to half of the original input or the original integer, which is also 1 and 2, right? So when we compare 2 and 1 to, 1 and 2 to 1 and 2, they are the same, right? Because this character you have here is the first one here, the second one too is the second one here. Now again, you always have to keep in mind that a palindrome is a string, is a sequence of characters whereby when you reverse the palindrome or the string to, let's say, when this is our original string, right, 1 2 1, when we reverse this string, right, to 1 2 1 again, it will read the same. So the reverse form of the original string reads the same as the original, right? So that is what makes a string a valid palindrome, right? So let's so we use the half version to do that. So I'm quickly going to. So how? Why do we use half, right? Why do we use half instead of the entire string? I mean, the entire string, reversing the entire string will work, but this time around, if we manage to shorten it, right? If we manage to shorten it, it will take us less time to compute, right? So instead of computing for every character and the total amount of integers we have here is 4, we'll just do for half, which is 2, right? And which that is also faster. So let's take a look at the case of a linked list, right? So another call coming in. Sorry. finally, I am done with the calls. Hopefully. Okay, so let's represent, you know, a linked list, right? So our linked list is going to look like this. So we have one connected to two, connected to, there's another two again, and the last node will be one, and this will be the end, right? So this will be none. Okay, so um what do we do here? So first of all, we take half of this linked list, like, right? So half of this linked list is from here. Now, how do we get half of the linked list? We'll use the slow and fast pointer, right, to get half of it, which is a much more effective way to, getting to the middle of a linked list. So the slow and fast pointers work this way. So we have a slow pointer here and a fast pointer here, like this. I'll just represent this with the fast. Yeah. So that will be my fast pointer. So here's how it works. So in the first iteration, they're both, before we start iterating through the string, right, through the nodes in the linked list, we'll have, both pointers at the same position. But when we start iterating, right, we'll move the fast pointer 2 steps ahead. So we would have moved this here, right, and then move this one by one, right? So for every 2 steps this fast pointer makes, the slow pointer makes 1. So this is going to be from this point, that's 1 and 2, right? And our slow pointer would have moved by 1, and then the fast pointer moves again, 1, 2, and then we move our slow pointer to this point. At this point, the fast pointer will point to none, which makes it, this will basically interrupt the iteration and end it here. So we'll know at this point, right, our slow pointer would have been at this position here, right, would have been here. So we know so this node, right, this is going to be 2, and every node it points to, right, 1 and none, right? So this is half of the original linked list. Now we are not modifying the linked list, we're just taking half of it, right? When we take half of this linked list, right, we'll then reverse it, right? So I showed how to reverse a linked list yesterday, so you can have a look at that, from either the basics of linked lists, right? The link is in the description. You can have a look at that, try this out, manipulate it, and try to see what you can get out of it. But basically, we're just going to reverse the linked list, right? So this is a reversal. The reverse, okay, so this is a function that reverses a linked list. So basically, we start with the head, and then we change the head's next value to a none, right? So the head becomes the last node, or the tail, right? So in this case, right, this would be our head, right? So to reverse this, we'll just simply take this head, point its next value to none, right? So we'll do this 2 will point to none, and then this 2 again, right, will have a previous value of 1, which is our which used to be our last node, and this is the reverse form of this linked list. Now when we get the reverse form, we'll compare it to half of our original string, half of our original head, right, or half of the linked list, which is this portion here. Now how do we get half of this? Well, you might be thinking we'll need to iterate through this entire linked list, but that's not what's going to happen. We're just going to loop, right? We're just going to loop based on the length of this linked list, right? This reversed half that we have. So in that case, where we are iterating and we get to a point where the last node of the reversed, right, the reversed node is none, right? When we get to this point, we stop the iteration, and we already know by the time we stop the iteration, right, this would have reached here, right? It would have reached this part of this linked list here, or these nodes, whatever we want to call it. It can be called nodes, right? This is a group of nodes, this is just a portion of the actual linked list. So yeah, and when we make our comparison and the values are equal, right, we'll then finish the iteration and return true. But in the case where the values are not equal, we'll just return false and end the operation at once. So let's go ahead and implement this. I normally, so let's see, this is 2130 maximum. Okay, no, not this one. This is the palindrome one. 234 palindrome linked list. So I'll call let me bring this back here to this side. So array stacks, where's linked list? Linked list will be here. So I'll create a Python file. What's it called again? Hold on. 234 palindrome linked list. Okay. I'll say lead dash 234, right, palindrome linked list. I'll put LL for linked list. Okay. So want to check if a linked list is a palindrome, and instead of, so I'll just copy this, the boilerplate, right? So this is I'll remove the optional part here, right? This is going to be a list node. Let me take this part. Okay, so we have a list node there, and what we need to do now is to get half of the linked list, right? So how do we get half of this linked list? Well. So we start with a slow. I'll call this slow. Slow is going to be equal to the head. They are started from the same position, and we'll need a fast pointer as well. So this will be head again, and then what we need to do is to start, iterating. So traversing the original linked list to get to the middle. So here's how we'll do it. So say wow, there is the fast node, and the fast node has a next value, right? Fast.next. Then we'll just say slow is going to be equal to slow.next, right? And then fast is going to be equal to fast.next. And since we said the fast will move 2 steps to one, I mean 2 step against one of the slow, so we'll just say next.next like this, right? And at this point, we would have got it to the middle, so our slow pointer now will be in the middle, right? So I'll just say, now we've gotten the middle, so what do? We reverse it, right? So I'll say what do I call this? I'll say, let me just create a copy of the slow. So I'll say copy, I'll say slow. Okay, let me call this slow node, right? This is going to be my slow node, and I'll set this to the slow, right? And then I want to reverse this, so I have a slow, and then I'll create a previous should be equal to none, right? So this time around I want to use this to reverse the linked list. So I'll say, to reverse the linked list, I'll just say while we have a slow node, right? Slow node, I want to why am I even calling it slow node? I should have given it a better name. It should be more descriptive. I'll call this half node, right? Yeah, so this is going to be half, and I'll call this half as well, half node as well. So yeah, so we have the half of the node, and so we'll say new node or previous node. I'll call this previous node, previous node is going to be half of the nodes next. Sorry, half node dot next, right? And then we'll set this half nodes next value to the previous dot next to be equal to the previous. The previous now will become the half node, right? Previous node will now, the previous node, I want to use a better name convention, right? So instead of calling it, I'll call this next node. Yeah. So previous will become half node, right? And then we'll set the half node now to be equal to the next node here. All right. So by the time this is done, we will be, we'll have the last node, right? The last node, which is the last node in this half node here, right? We'll have its value set to previous, right? And previous is basically a node, and we know while reversing we are connecting nodes to each other, right? So by the time we get to this point and we reset half of this node, right, we'll have the last item, which is half of this node, point to none, right? Because half of this node here dot next for the last node is going to be equal to none, and this will no longer work. But we know by that time we've already set the previous to half of the node, which is good. So here's what we need to do. Now we've reversed it, right? So we need to compare, each value. So I'll just say, let me keep a copy of the I'll call this reversed half, right? Reversed half is going to be equal to the previous like this. And then I'll say wow. So like I said, we iterate based on the length or the size of this reversed half here. So while reversed half, right, while there's still a reversed half, we want to compare now. We'll say if reversed half dot value, right, is not the same as okay, I'll need to keep a copy of our original head as well, right? I'll say original, or I'll say current. Okay, I'll call this original node and set this to the head, right? So while this is not equal to the original node dot value as well, right, then we return, oh Christ, then we return false. We just return false. Otherwise we just keep resetting the reversed half should be equal to reversed half dot next, right? And then we'll say original node should be equal to the original node dot next, like this. Okay, so with this we would have reversed, if we didn't get any false returns at this position, then we know by the end of this iteration all the strings would have been valid palindrome. So we'll return true here. All right, so yeah, that's it. That's all we need to do. First of all, we reverse, we take half of the original input, which is the head, right? And then we go ahead and reverse that half, right? And after reversing the half, we'll then compare the values in each node, right? In the half linked list or half node, and the original node as well. Now we are using the original node, but we are not going to reach the end of the original node because this will just iterate half the size of the original node, right? So half here is, what we are using to iterate, right? So this while loop will end once this half points to when the next value of this half is none, right? So meaning we reach the tail of this half and the next value here is none. So this would have changed and the condition here is no longer going to be valid and the loop will terminate here. Now in the case where we never got to this point, right, we just return true, right? So we return true, which means the input or this head here is a valid palindrome. So let me copy this and run it in LeetCode for us to see the outcome. So I'll just take this here. What do we have here? Define. Yeah, so let's run this. As you can see, this has passed the test cases. The runtime is 29 milliseconds. I'm not sure if this is going to be effective, but yeah, hopefully the solution works, right? That's the first thing we want. Of course it did, so which is nice. All right. How many test cases were there? How many test cases? So there is a maximum twin sum, which is this one here. I've already chosen this question to solve, so which is going to be our next question we're going to solve. So let's see. Oh, you can add notes to. Okay. So what are the steps we took? First of all, we took half. I think I can do this. Can I do? Is this a markdown? I think markdown is going to be like this. Steps. Will this work? Nah, it will work. So I'll just say steps. Steps is going to be equal to first step. Take half, right? Okay, it's not take half, but we get the middle node. So I'll call this get middle node. Get middle node. And then the next thing I'll do is reverse the middle node. I'll say reverse middle node. And the next thing is after reversing, compare values in reversed middle node against the original node, which is the head. So I'll call this original head, and against the original head with so compare the values. So this is reversed compares values, node values, right? Node values in reversed middle node against the values node values in the original head node, and by iterating, I'll call this iterating with the size of the middle node. Yeah, so this is all. What's this tag? All right, that's it for now. Let's choose another question. So the next question to solve is this maximum sum twin. And you see they are quite similar, right? These questions are very, 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 very similar. And it's just going to be the same step we'll take to solve this one as well. So let me quickly commit this, right? I will say oh, not that. Is what I want. Git add, git commit dash m. This will be um, linked lists, right? Uh, valid palindrome, valid palindrome, like this. Okay, so let's go ahead and start our second question. Our second question Our second question is it's called maximum twin sum of a linked list, right? A linked list of size n where n is even, right? Size n where n is even. The ith node, right? The ith node when we are doing zero indexed, which means we start counting the node or the position of each node from 0. So the ith node, zero index of the linked list, is known as twin, right? Twin of the n minus 1 minus ith node of n minus 1 minus ith node. If 0 is less or equal to I, and I is less or equal to n divided by 2 minus 1. For example, if n is equal to 4, right, then node at position 0 is the twin of node at position 3. Node at position 1 is the twin of node at position 2. These are the only nodes with twins, right, for n equal to 4. Okay, the twin is defined as the sum of the node and its twin. The node and its twin, given the head of a linked list with even length, return the maximum twin sum of the linked list. So here is what we have. Here's an example. So we have the head like this, right? So 5, 4, 2, 1, right? This is our linked list. And our output is 6. So the maximum twin sum here is 6. So the twin is basically 2 nodes. We'll add those 2 values, right? We'll add those 2 values and see which other, operation or adding of twin nodes has the maximum result, right? So when we add, so 5 is the twin of 3. You can see it's like the position at which they are is similar to what we have in let's say in the case of the palindrome, right? We know the last item is going to be the twin of the first one, and then we move one towards the middle, right? We move the left side, right, one towards the middle. The right side one towards the middle, right? And the left side is going to move one, so we add 1 to it to move it towards the middle as well. So we know the twin of each one of these items, right? So when we start from the beginning, it's going to be n minus 1. N minus 1, when we start counting from 0, right? If the length of this array is 3, right? It's 4, then n minus 1 is going to be 3. And 3, since we start counting by from 0, 3 is going to be the last item in the array, right? And minus I is basically minus 0. So this will still give us 3, right? Which is what this part says. So let's take a look at how we can find the maximum. And each time we find two twins, right? When we find no, sorry, not two twins. When we find a twin, we add their values, right? And we set that as our maximum. When we add the values of another twin, and the value at this point is bigger than the previous one we calculated, then the current twin has the maximum sum, right? So let's go to this part here. Let me just bring this here. I'll take this down. Oh my god. Let me take this. Okay, I'll just represent this, right? So this is 5 4 2 1. 5 4 2 1. So we have the node this way. Our node is 5 4 2 and then 1, right? 5 4 2 1. Now this is the first node, right? So we want to find its twin. Its twin is going to be this first node here. This is its twin, right? And this second node here, right? Now you can see whenever we move a step, let's say we have, this is the left and this is the right, right? Whenever we move a step towards the next item in the list, or towards the next node, the right one too moves one, right? It moves by one. Basically, we add one more value to this, or one more 1 plus whatever the value of this left is, and then we reduce our right by 1 as well, right? So we reduce this one by 1 and we are at this point. So that's how we'll be able to move this or find the twin of an item. But again, when we do it that way, this will cost us a lot of operations to do, right? Because we are just going to look at the items instead of taking their values. So for us an easier way for us to do this is to take half, right? So we divide this by 2, or we take half the nodes that are in this linked list, right? Now this time around, since we have half, right, we know the beginning of, or the twin pair of this particular node here is going to be the last item in this linked list, right? In this second half, I'll call this second half, right? So for us to properly assess this, we need to do what? We need to reverse this, right? So this becomes 1, right? And then 2, right? So we'll have 1 and 2 instead of 2 and 1 in the half. Now we know that for the first item in this original linked list, or this original node, right, which is also, we can also refer to it as the head, right? For the first node here, its corresponding twin is going to be the first node in this half, in this reversed half. So that way operations will be easier for us to do. So we can just iterate based on the length of this second half and add the first values, right? The first values at each point. So in the first iteration, when we add 5 to 1, we'll have 6, right? So our current maximum here is going to be 6. And the second iteration, so we would have moved from this point towards this point, and from this point here towards this point here. So this is going to be 4 and 2, right? So this is going to be 4, and 4 plus 2, this is 6. We'll compare these two values, right? Which one is the maximum? They are all the same, so we just say C is equal to 6, and this will be the value we return in our function. So that's all we need to do to solve this. And yeah, so there is no constraints, there's nothing more. But when you read the hints, right, the hint says, how can reversing a part of the linked list help find the answer, right? So which is what we did. We reversed the linked list. We reversed half of it. Now a second hit is to, we know that the nodes of the first half are twins of the node in the second half. So try dividing the linked list in half and reverse the second half. So the hints are there. How can two pointer be used? We are not going to use two pointers, but to find the sum optimally, right? So, I mean, if we are going to use two pointers, then we need to know where the last node is, right? And then we'll just move the pointers towards each other, right? So we start a left pointer at the beginning and the right pointer at the end of the linked list. So the fourth hint says use two different pointers pointing to the first node, okay, of the two halves of the linked list. The second pointer will point to the reversed half, which is the by moving the pointer to forward each time we can find the sum. I mean, it's basically the same thing. It's yeah. So let's see that in code. Again, I'm just going to copy this, right? I could just do the implementation here, right? I could just do it here and copy the value and then paste it here. But the conversion is such that I always do it here first and in my code editor first. So I'll copy. So this is 2130 maximum twin sum. 2130 maximum twin sum. 2130. So I'll copy. I say leet dash 2130 max twin sum, right? 2130 maximum twin sum, and then I'll just use this like that. I'll remove this optional here. We don't need it. That's for LeetCode themselves. So next or none. I don't really like the way they did this, but our problem is not here. So we want to find the pair sum, right? So I'll say, is it pair sum? Hold on. Oh, it's pair sum, okay, instead of twin sum. All right, I mean, pair and twin are all the same stuff. So first of all, we need to take half of the linked list, and we know how we get half of a linked list, right? Or the middle node. So we start with a slow and fast pointer, right? Slow, and this is going to be the head, and the fast one is also going to be the head as well. Now we'll say so we iterate and increase this each time. While we have the fast dot next is not none, right? If the fast dot next is not none, then we do this. We'll say slow should be equal to slow dot next, and then fast should be equal to fast. For every step the slow makes, the fast pointer has to make twice the step. So fast on next, and at this point we would have had the fast. So I'll just take I'll call this middle node, right? This is going to be equal to slow. So slow, and we'll reverse this middle node now. So how do we reverse? Well, we will need a previous value, right? Previous is going to be equal to none, and we'll iterate through this this node, right? This middle node, and reverse it. So we'll start with this. I'll call this middle node. So while there's a middle node, while middle node, right? We want to set the new node I'll call this not new node, next node. Next node is going to be equal to the middle node. Middle node. We set previous. No, we don't set previous here. We set the middle node here. So next node is not middle node. Middle node dot next. Right. Sorry. Middle node dot next. Middle node dot next, and we take this middle node now, and we set the next value to be equal to the previous, and then we take the previous and set it to the middle node, and we go ahead and change the middle node to the current node or to the next node. We change this to the next node. And what do we do next? So yeah, basically this will reverse it for us, and the value of the previous, this previous here, is what we use, going forward. So that is going to be our reversed half, right? Reversed half. So I'll call this reversed half. Reversed half is just going to be equal to the previous, and then we'll use this reversed half length to find the twin pair, right? So the maximum twin pair. So we take the reverse half, right? While the reverse half is still there and it's not equal to none. I don't know why I keep doing that. While the reverse half is not none, right? We want to take the values in both the original and the reverse form, right? So I will say I'll call this local sum, right? Local sum is equal to the reversed half dot value, right? Is it the value of val? Okay, the value plus so how do we get the original? So let's copy both of them. So I have original node is going to start from the head. Yeah, is reversed half good? Does it really say the reversed half node? Yeah, reversed half node. I'll call it that way. This will be easier for me. So the reversed half node plus the reversed half node value, right? Plus this original node's value. So I'll call this original node, right? Original node dot value. So here we'll get a local sum, and let me create another variable here. I'll just say max sum is going to be equal to 0. This max sum is what we return at the end of the day. So every time we calculate the local sum, right, we'll just compare it with the previous value of the max sum. So this is going to be max sum, right? Sorry, max between max sum and the local sum here, right? At the end of the day, we return the max sum like this. So there you go. 3 steps. First, take the middle node, reverse the middle node, and then compare the values. Now you might be wondering, okay, if we're using the original node, won't it reach the end of the array? No, I mean the end of the list. No, what's going to happen is the reverse node is already half, right? So we are just going to compare it to half of the beginning nodes in this particular original node, and that's all we need to do. So let's copy this and try it out in our LeetCode console. I'll just put this here. So let's see. Let's run this. This should work. Unless there's some errors. Oh, I know what happened. I know what happened. This is going to time out. This is going to time out because yes, this time I see the mean. The reason why I did that is because we are comparing values here, right? But we are not resetting the half node, so this is just going to remain the same, right? And this will never, uh, evaluate to the point where the next node is equal to none, right? So instead of doing it this way, I'll say the reversed half node is going to be the reversed half node dot next, right? And the original node, so we move them forward. Original node is going to be equal to original node dot next. And that way, ladies and gentlemen, we will have the answer we desire. So I just copy this part here. That's all we needed to do. And I will just take here. So there you go. Let's bring this back here. So run this, and this should work now. Yep, the test cases have been passed. So let's submit this and see what we get. Okay, it is not the most effective solutions in terms of runtime, but it works. It works. I mean, we're using less space. Well, is the question asking us to, optimize this? Say, seen this question before. The number, blah blah blah. Okay, so there is nothing like that, so we're good to go. All right, so that's about it. I will also do the same thing here. I'll say git add. Oh, come on. Git commit. This will be 2130 leads. I'll say what's the title? How did I, linked list, right? So linked dash list, twin sum. I'll call this twin sum. Like this. Twin sum max. Yeah. Okay, so that's all. Okay, so let's go. Right, so we're done. All the solution will be available in the description. You can have access to them. And yeah. Oh, there are some questions in the chat. Hey, I see engineer has been coming to this class almost every day. There's J says, hey, hello. Andrew, hi brother, how are you doing? I'm good. How are you too? There is Sorav. Let's go. Yeah. Okay, so where am I studying these things from? Pretty much I'm mostly after getting free, please reply. Okay, yeah, sure. Oh yeah, so where do I get everything I study from? Basically, you can get from Geeks for Greeks. You can use LeetCode.io, and also if you have money, you can use ChatGPT to help you explain some of the concepts so that you can really understand them and for you to be able to solve these questions. Sorry, I must have skipped Alberto. So hello Alberto, welcome to the stream. Welcome everybody. Wow, there are a lot of people today and I'm excited. So we solved 2 questions today, which is really good. Let's see. Here I haven't got so much time more, but tomorrow So what I'm thinking to do tomorrow is to revise everything I've been doing so far. But um, okay, which is easiest to start? The easiest to start. I'm not sure what you're asking me, but if you want to know, the starting point, I think, luckily I opened this today, right? But I don't really use this all the time. I also used neat code, right? I have a neat code account, that I use to study, from time to time. So you can also get neat code if you want, and if you have the money to afford it, you can use neat code as well. But most of the times, I I don't I don't I don't rely solely on this, right? You can use a lot of resources. Even after having this account, I barely, used one resource. I use a lot of resources. I go from, YouTube videos, ChatGPT for, more in-depth explanation and so on. Uh, Yeah, I have Neat Code Premium. He's running a promo currently. I think he's doing like a 25% off. Although I got this account in the early stage, right, of Neat Code, where he just started, the platform, and there was a huge discount. He gave me a huge discount. Shout out to Neat Code, and I'm really grateful for that. So I've been using his platform as well. So this is to help you study, right? And all of these things are just to show you what to do. But the real part of this whole thing is to repeat, right? When you study something, repeat it over and over again. Solve them, once again. Like, you can solve the same question about 5 times until it sticks. And when you see a similar question, you just use that same pattern and use it to solve the question. So I mean, engineer has been here for, so yeah, that's it. That's what I do daily. So I spent about, how you decide which question to solve when any list. Okay, so basically, and when to revise. Okay, so basically, you don't get to decide per se, but like, let's say for instance, when you do a lot of research, right, you will begin to find a common way to start, right? Let's say for instance, you have arrays and strings, understanding big O notation and so on. And even then, big O notation, understanding big O notation shouldn't take you more than, um 2 hours to understand, because it's nothing really. It's just knowing, the terminology to use for how well your code is performing. It's not the actual problem solving trick, right? So the real part is knowing the algorithms. So let's say, for instance, arrays. You have to learn about arrays, understand what arrays are, the kind of operations you do on arrays. Like on my playlist, I basically follow a certain pattern after research, right? You can, even if you have ChatGPT, ask ChatGPT for some ideas, then use that to compare to every other ones you see online, and then just pick together. And so me, I started with arrays and strings, right? Although in that part they are not very much, uh, they are just day to day kind of operations you basically perform as a programmer, or as someone who codes, right? Arrays and strings are like very basic stuff you do. I'm not saying the questions are going to be basic, but uh, okay, so you want to know my ideas. I'm not saying array questions are going to be easy, but like, what I did is I started with arrays and string. If you look at the one was about arrays and string, and you know, uh, okay, so you start with, okay, how do I solve the questions? Okay, that's a very good one. So here, let me show you an example. So what I do is, you see, there's array here, right? There's array. So what I did is I took arrays, right? I took arrays, and then I'll just do this. I will sort the questions from easy to whatever. You can see I solved a lot of easy questions, although I didn't solve much of arrays questions, but there are a lot of easy array questions. And I'm sure most of one trick about LeetCode is, when you look at the acceptance rates, right, you know how difficult a particular question is. So going down, right, you'll see the acceptance rates begins to decrease, which means the question was either a little bit confusing or difficult. Going down, you can see it reduces to 68 and so on. So you solve as many as you can, right, every day, and solve one question at least 4 to 5 times until it becomes second nature to you. Then after you are comfortable with, like, after solving about 20 easy questions, over and over again, the same questions, you can then move on to the medium part. Although I only solve one medium question in arrays, so I will do that later on. I'll continue solving more and more medium questions. So I also have this medium question here, right? Yeah, I mean, just choose some random. You don't have to solve everything. Just choose some random questions and solve them until they are, there's a lot of questions here. I'm not sure all of these questions are only arrays questions, but when you see, another trick is, let me just move forward. Let me move up. Another trick is to see the tags of that question. Let me take, for instance, this palindrome question here, right? When you go to the description and you look at the topics, it says linked list, 2 pointers, stack, recursion, right? So if you know at least 2 algorithms out of these 4, then you are good to go. This basically means it's a linked list problem. You can use 2 pointers to solve. You can use stack or recursion, right? So if you know 2 out of this, right, or even 1 out of everything, it means you can solve this question, right? Although I would recommend it's 2. Basically, 1 should be what the question is based on, which is linked list, and 2 should be 2 pointers and so on. Like which questions and array? So you come here, you come to LeetCode, click on arrays, right? It will take you to all the problems that are tagged with arrays, and you can just find the ones you can solve, right? Just look for the ones you can solve, and and solve those ones. So that's all. You can see, okay, so another, so when you enable this, okay, I didn't even know this before, I'm just finding out now. When you enable this, it will show you all the tags, right? So this is a two-sum problem, although you don't need to know hash tables. I haven't learned hash tables for now, but I have an idea. It's going to be dictionaries in Python, but I don't really know much about hash tables. But so here's what you have. You have 2 pointers, really, and so on. So when you look at, from day one, I've always followed the pattern, right? You don't need to watch the entire video. Just read the titles and see, titles and description, and see the questions I set for that particular session and so on. All right. Thank you very much. Okay, you said you've got it. All right. That's it for today. We'll see you again tomorrow. Right? All right. Take care. Bye. Oh, don't forget to subscribe. I've not said that before, but, like, yeah, don't forget to subscribe.